Michael Schmid, always one of the first people in here. Appreciate it, Michael. Good morning out there, everybody.
Good morning, everybody.
Good morning, everybody.
All right, we should be live on everything, YouTube, LinkedIn, Twitch. Good morning out there to the global OpenCV audience. Please let us know where you're coming from as you filter into the chat here. We'll be getting started with the show in just a few minutes, but as always, as usual anyway, I'm coming to you from beautiful downtown San Francisco, California, and our illustrious host, Satya, is joining us from
San Diego, California.
And our guest, Daniele.
Northeast of Italy, Udine.
Excellent, excellent.
Colorado, Alexander from Colorado.
Good morning, Colorado. Good morning to Roland on LinkedIn. Yeah, please let us know where you're coming from. Good morning, India.
From India. India is a large country.
Yeah. Where? No, he's just amongst from all of India. Just good morning, Athens.
Greece.
I was just talking to somebody from Athens, Georgia. Good morning, India on LinkedIn. Good morning, Italy. Good morning, the Coconino Forest. Good morning, Nigeria. Good morning, Switzerland. Good morning, Brazil. Good morning, Florida.
Wow, from people from all around the world.
Yeah, good morning.
An exciting show.
Good morning, Gay Paris. Good morning, Costa Rica. Good morning, Ontario. I was just in Ontario a few weeks ago, as some of you may remember. Of course, it's 9:30 p.m. in India. Good evening, India. Well, I guess it's actually just 9. Good morning, Tunisia. Good morning, San Francisco. It's an easy good morning for me. Super close. Good morning, Romania.
Well, some of the people you're saying good morning to may not be in the morning phase anymore.
Yeah, well, it's morning for me. I'm
Right.
saying good morning. That's
okay.
Good morning, Munich. Good morning, Berlin. Yes, good evening again to India. Lots of India as always. One of our biggest contingents every week.
All right, should we get started?
I think let's see, what do we got here? Yeah, let's
live streams are live.
Yeah, we're live. Let's go ahead and get started.
All right. Good morning and welcome everyone to OpenCV weekly webinar. I'm Dr. Satya Mallick, CEO of OpenCV. Artificial intelligence and machine learning technology are taking the world by storm with surprising results for art and creativity. One aspect of machine learning revolution that isn't discussed as much is its effects on industry and automation of dangerous work. Our guest this week is Daniele Fornasier, who is here to tell us how AI and ML work for industry. But first with me, as always, is Phil Nelson, Director of Content and Creative at OpenCV. Phil produces the show, so if anything goes wrong, it's probably his fault.
Yes, thank you, Satya. It is me once again, the co-host with the co-most, the second banana who is second to none. I'm also your plus one and only. It's Mr. Nelson if you're nasty, but you can call me Phil, and I'll be your Huckleberry. But first, I'm here to remind you of a few things we do every single week here on OpenCV Weekly, the first of which is a special giveaway to you in the audience. Stay tuned. Later in the show, we'll be asking a trivia question. You'll be able to answer that question, and the first one to do so correctly will win the OpenCV course of their choosing, including the upcoming OpenCV Mastering AI Art Generation course, which just had a successful Kickstarter campaign and is now on Indiegogo. You can still save big there. Satya will talk about that in just a minute. But first, we're also taking questions from you in the audience. Use the Zoom Q&A button at the bottom of the screen or ask your question in the chat system wherever you're watching, YouTube, LinkedIn, Twitch, whatever, and we'll do our best to try to flow it into conversation as time permits. Before we get started, Satya, you want to talk a little bit about moving the Kickstarter campaign to Indiegogo after a successful funding there?
Yeah, so the Kickstarter campaign was a huge success. We raised more than 140,000, I think 142K or so. And now we have moved it to Indiegogo where, we will get new audience. The funding will increase a little bit, but we are not spending as much time and energy on marketing it. but you can still get a great deal on Indiegogo. It is still not the retail price. So you can still get the great deal on both the courses. So if you're interested in AI art generation, which you should be, it's a very fun thing to do. I never thought of myself as an artist, but when I'm playing with this thing as I'm creating the course, it is just a fascinating world. I mean, I'm just blown away every day seeing what AI can do, and also a lot scared. I'm getting more and more scared with what AI can do, not just in terms of job losses and other things
Welcome
that
to
will
the club,
happen
pal.
inevitably, but also it's scary how realistic these things are. And there is always this scare of how they can be used in nefarious ways. Like
the potential for disinformation is like extremely high. It's I think probably the biggest, most pressing danger with AI stuff currently, especially as we're gearing up for another election season here in the US.
Oh, there was this photo of Trump being arrested, which looked very, very realistic until you went to, in that series of photos, they had one photo where they had Trump running, and that gave it away.
Yeah, I mean, a boy can dream. I hope that we do get to see, Trump take a perp walk one of these days, but those were not real, unfortunately.
Well, yeah, let's not get political. I just thought that him running was hilarious. It was very realistic. I mean, the whole pictures that they had created, they were pretty realistic.
They almost kind of looked like like a Saturday Evening Post illustration or something. Some of the ones I saw, they were pretty funny. But anyway, on with the show.
Today we are here to discuss other interesting things, about automation and how computer vision can help in preventing dangerous, monitoring dangerous work, etc. So Daniele, let me pronounce your name correctly this time. I'll try my best. Fornasier. Is that close enough?
Almost perfect. Almost perfect. Yeah, thank you so much.
Thank you. So yeah, take us, give us a short introduction of yourself, and then the show is yours. We'd love to see what you have got for us.
Yeah, sure. Take it away. Welcome, Daniel.
Hi to everybody. I feel pretty happy, pretty excited, and overall pretty grateful to Satya and Phil that allowed me to share this webinar and my professional experience on such a topic that is industrial AI. So the title of the webinar that we are taking so far is From Ideas to Prototype, because I think it's very important to have the right path that may lead engineers from the idea to the proof of concept and then to the industrialization of the product. And this is especially true for young engineers. And during the webinar, I will show you what are the results that a good training path may help engineers in order to become really, really effective using this kind of technologies and delivering absolutely astonishing results. So just a few words about me. I am Daniele Fornasier. I graduated at the University of Padua in 2004, so almost 20 years ago. And I spent since after my graduation in computer theory with a focus on control theory, I spent almost all my professional life in industrial environment with R&D, applied R&D, with a focus on contactless measurement and quality control. This is a picture. I was in Australia, and behind me there is, you can barely see perhaps, a rolled, a not forged wheel, 1000 degree, and there is a laser-based contactless system that was able to measure very accurately. What I want to focus, to point out with this image is that when you are related with industrial environment, your outfit is the one you are looking in the picture, that is an helmet, the work suit, the safety shoes, the glasses, and so on. And I spent almost 50% of my career inside the plant and directly on production line, because as we will see in the follow-up, it is very important that the engineer who designed the prototype then go directly to the plant in order to commission and to roll out the solution. It's very important because there are so many things that you will see just in the production line.
Mhm.
So this is the main point. In this moment, I am the business unit manager in BioNTech of the AI and machine vision business unit, where we develop control and quality control and process control solution based on AI technology. So what I would like to show again is the conditions where we usually work, the plant. You know, there is a photo of a colleague of mine that is under a conveyor, and there is another one who is fine-tuning a GPU-based embedded camera for quality control, and we are going to see what kind of control he realized in that kind of environment. Again, it's very important to understand that why is so important, why I'm stressing so much in the final environment, because when you are delivering a solution in industry, there are so many stakeholders with very different goals. For example, you have the financial officer who wants to spend as less as possible. There is the production officer who does not want to stop the production for your test. The quality manager who wants an almost accurate, the most accurate system as possible. And you also have a lot of workers, operators, that in some way it's very important to provide with easy to use equipment, because there is something to say about that, that sometimes we forget that the final users in industry, and you can realize that because the user interfaces and the user experience in industry, in automation, is still very, very poor with respect to websites or to flat UIs that you currently have experience with the mobile applications. For example, I always say that my granny, who is almost in her 90s, uses WhatsApp. And this is very important because I told to my colleagues, we have to make the same thing for all those people working in industry. We have to hide the complexity of the AI-based solution. Their interaction with the system should be as easy and natural as possible, because otherwise they won't use the system. I had the chance sometimes throughout my career to see very good control system, but they had a bunch of parameters to be fine-tuned, for example, during a production change. But one day I made an experiment. I asked to a colleague of mine who was working to another product line. I told him, come here and fix the recipe, the fine-tuning of 20 parameters for this new product. And it took about 1 hour. So I told to the boss, if a computer vision engineer has to work 1 hour to fix a recipe, how it is possible for an operator inside the industry who does not know what is edge detection or half circles and so on. So it's very important to deliver a solution that is not only robust, but who is very easy to cope with when you are changing production and production conditions.
Yeah.
So what are the main needs that we are facing in manufacturing? What are the questions that are arising from the market and from our customers? Repetitive actions, as you can see in the first image. Quality control. There is plenty of industrial processes where human quality control on the total percentage of production is still active, and are those are very, very difficult and grueling jobs because, for example, when you are producing glass bottles, I took this picture. The main shift between the turnover of the people who is undertaking quality control is 15 minutes. Is really frustrating and alienating kind of work because you have to check for small cracks inside the bottle in front of a backlight.
So after every 50 minutes, they change the people. They ask them to rest.
They make turn around.
Wow.
Absolutely.
And that's partly for like eye strain purposes and fatigue and things like that. I think it's, a lot of these things, and I'm sure you'll talk about this some more, is that it's about mitigating people making mistakes due to just being too zoned in, like you stop noticing things after a while.
Yes,
and it's
absolutely.
also just bad for your body too.
The level of the attention goes down quite quickly.
Yeah.
Right.
And then there is also the harsh environment. I spent much of my industrial time in rolling mill and melt shops, and I will show you one of the solutions that make a big change in this kind of technological process because it was impossible to free the potentiality of an electromechanical device just because this device was designed to work on very hot, let's say 800, 900 Celsius degrees. But the problem was that no human operator could go toward the metal at that temperature.
Right.
So what are the three pillars we are working on, the three different...
There's another example in the same category, which, windmills. The inspection of windmills is also very dangerous. They do it using with a person hanging from a helicopter, literally, right? Very close to the windmill, which is a very dangerous thing. And now they are switching it over to drones, right? Drones can do it with, and then they are adding automation to it. But that's how windmills were inspected, which is extremely dangerous.
Absolutely correct. Same thing applies to windmills.
Yeah, bridges, high voltage electric wires, things like that. I'm seeing more and more, like even here in the Bay Area, when they do inspections on like the Golden Gate Bridge, this iconic thing. Right. I'm seeing more and more. It's drones taking care of some of those extremely dangerous tasks, which is really cool to see.
Yeah. During these days, we are delivering a dimensional control for hot forged blooms that are big round objects in melt shops. And so far, a human operator with a caliper goes direct toward this incandescent bloom and take the measure. It's very dangerous. And
that's insanely hot things.
Yeah,
right?
insanely hot. Insanely hot. So the new kind of paradigm is zero man on the floor. You don't want to have people on the floor of such dangerous environments. So it's of paramount importance both for safety of operation to remove these people from that danger and to replace them using proper contactless technology. So what are the different pillars we are working on? First of all, intelligent automation. What do I mean by intelligent automation? Traditional automation, let's say PLC, motion, and so on, were more or less a list of fixed instructions that repeatedly were executed. What do I mean as intelligence? Is inserting a new kind of sensor, a neural network, an advanced vision system inside the automation loop and promoting directly on the edge a human cognitive-like capabilities. For example, estimating the quality control of a product and then feeding back a kind of signal directly in the automation loop, something like that. And this is one of the most wide and open spaces for introducing this kind of AI-based technologies directly into industries. And in this moment, if we compare, for example, just to 5 or 7 years ago, we have very, very fantastic hardware and libraries to perform real-time calculus directly connected to the automation devices. It was virtually impossible sometimes, let's say 5 years ago, to deliver such a solution, even if you can prototype them in a lab or at least conceptually, but not realizable directly in the plant. Second pillar is human decision boost. You know what I mean, human decision boost? When you are dealing or driving a very complex production line or a plant, there are a bunch of different data according, for example, to process parameters like pressures, like temperatures, like chemical addictions, and so on. And sometimes, due to our limited nature of our memory, of the capability to make correlation between data, it's very difficult to have an average, let's say, behavior and performance of the plant. Once after a conference, the CTO of a big OEM producer here in Italy came to me and he told me, I don't want AI to overperform the human behavior. I just would like to leverage AI techniques in order to have a very good average performance of the plant. Because sometimes when you have the local hero, let's say the person, the worker that has a long experience, you are able to drive the performances of your plant really good. But sometimes when he's off the shift or something like that, it's very difficult in some kind of process. I'm thinking about rolling mills or similar chemical process in order to drive as accurate as possible. So we are going to see some of the application that may give very good insights on how the process is going and help, because we are analyzing a lot of data in different points, visual data, and we are putting this data on an historical database. This is one of the differences between the human approach and a structured technical approach. Last one is process innovation, that is making something new with new techniques that was not possible with previous techniques. For example, using a cobot and a camera to make a kind of control where before you used a couple of human operators to inspect different parts of a 3D big object, for example. Or for example, in another kind of application, to move from an electromechanical counting of bars in a rolling mill using, for example, a contactless camera with no kind of interaction from the mechanical point of view with the moving material, and just counting the bars with superior precision, superior to the mechanical contact solution. So what is the toolbox that we are using? What are the instruments that we are using in order to deliver such solution? Advanced automation tools, first of all, soft PLCs, where we have an operating system like Windows or Linux, and real-time capabilities in order to be able to use field protocols like Profibus, Profinet, and Digital I/O to connect directly to the level 1 automation on the shop floor. Robot and cobot to perform the displacement of the camera or to command pick and place after a camera inspection on the scene. GPU-based high-performance computing for sure, using NVIDIA, but also using now, we are scouting the VPU word that is quite interesting. And Last, machine vision and advanced sensing. So cameras, smart cameras, embedded Linux cameras, and also thermo cameras in sometimes or laser profilometers. Those are the instrument we are using.
I noticed, if you don't mind me butting in here for a second, I noticed you've used the phrase cobots a few times, which is awesome. I first heard this from Alex Glow, the host of Hackster Cafe, our friend Alex, who's been on this show. Have you noticed this phrase being used more in your line of work over the last, maybe this year, or is it an older phrase out there?
Sometimes the cycle times required implies that you are forced to use common industrial robots. In other places, you may use cobot in order to avoid all the safety regulation that are required when you are using an industrial robot. For example, photocells and similar devices. It really depends on the specific application.
Yeah, cool. I'm used to hearing it in the context of, cute little robots that take photos and things like that.
Okay, let's go on. So, what is the right approach when a customer asks for a solution? First of all, we must say that in the majority part of the requests, there is no already off-the-shelf solution. So sometimes it's very difficult to say, yes, we can, or no, we can't design or answer your needs. So it is very important to make a lot of questions and again, to involve all the different stakeholders in a preliminary feasibility analysis. Because according to my experience, when someone is telling you or describing the process and the need, sometimes they are ignoring some details that are really important from the technological point of view, from what you are trying to deliver. For example, sometimes you are asking, what are the range of colors? Oh, from black to white. Okay, are all matte colors? No, we have also shiny colors. And this may be changed completely. For example, the lighting apparatus. So it is very important in the feasibility to go directly again on the plant, to make a lot of questions, both to the quality manager, what kind of defects do you really want to inspect and to find out in production? Are they equally important? Are they equally statistically distributed? Because if you have a very difficult, for example, surface scratch that would require, for example, additional cameras or, let's say, a different light setup, does this is worth to add new hardware if its incidence is so small? Those are the main questions, because this kind of question has a direct impact on the technological solution that you are sketching up in your mind, and consequently in the economical effort and in the difficulty of rolling out that kind of solution. Then, if the feasibility analysis says, yes, we think we can go on and design a solution, there is also a good idea to make a prototype. What is a prototype? A kind of proof of concept. A very compact solution where you are only trying to figure out the core functionalities that you are required to deliver. So no particular effort on the UI, on the interconnection, but you just want to check how effective will your solution be once directly in line. It's very important because during this phase, if you were able to dig out all the very important details, you may build a prototype with a very limited effort, and you can put it directly on the production line, and you may say, hey, to your customer, come here and let's look how it is performing. So there is no a big economical effort. He may looks directly in his plant how the inspection or the control or the automation loop works. And you still have time to make some little fine-tuning, some fixes, and to make it work in order to help your customer in understanding the value of your solution. So they are always happy when things are good with the prototype, because it's much easier, to deliver a complete solution, because they trust you, they trust your solution, they look with their eyes directly in their plant how things are going. So it is very important to go through a prototype, through a proof of concept when you are delivering, especially a very complex solution. You have to break down the complexity in order to be able to cope with it.
So one other thing I want to emphasize here. So if let's say you have a computer vision problem and you're trying, if you're hiring a consulting firm to solve the problem, let's say you do not have things in-house, or if you're doing a project in-house and you're starting with the problem and you're in the prototype phase, one of the things that can be very attractive to you is that you try to solve the problem that you know how to solve first, right? And that's exactly the wrong problem to solve. When you're trying to, when you're in the feasibility stage, the problem, so you look at the problem, right? You know that, oh, I can do this, I can do this, I can do this. I am not sure whether I can do the, third step or not, right? And then if the third step works, I know how to do the fourth step, right? So in the feasibility step, the hardest problem is the one that you have to attack first, and then you go down and solve the easy problem. So a lot of times people want to show progress, right? People want to see, oh, there's this pressure that whether this thing, what did you do last week, right? That's a joke. I don't know how many people got the reference, but I lost my train of thought. But what I'm saying is that you should attack the hardest problem first and then the easier problem, because the whole point of a feasibility study is to see whether the problem will be solved or not. And it is actually unethical to show progress, especially for a consulting company. Like OpenCV.ai is the consulting arm of OpenCV, and we get a lot of projects from clients. So when we do our feasibility study, we attack the hardest problem first, right? Hardest part of the problem, so that we know it is out of the way, right? And we also, when we think about a problem, we think about it, there are two kinds of problems, right? One is a research problem and one is a development problem. When we say something is a development problem, we know how to solve it, right? It is just a matter of going through the process. When we say that it is a research problem, we do not necessarily know everything, right? We have some ideas, but we need to figure out whether things will work or not. So once you have that, right? So you attack the research problem first and see whether it will work or not, and then go to the easier problems, right? And if you cannot solve the hard problem, then you cut your losses and move on.
You anticipated, Satya, the next slide, and I strongly...
Oh, I'm sorry.
No, it's very good, because I strongly agree with you.
Yeah.
In my first job, I had a great mentor who is a mechanical engineer, perhaps the most the best engineer I have ever known throughout my whole career, and it trained me in the following ways. When you are facing a problem, try to break down the problem exactly as you told before, and just focus on the 2 or 3 critical goals. That's the point you have to focus in the first part. Do not bother with minor issues, the UI, the connection to the MES, the ERP, the automation. No worry, we know that it's just a matter of man days in the final quotation. No problem, it's just development, it's state of the art. focus on 2 or 3 critical goals. For example, are you able to set up the correct lighting apparatus? Are there any kind of mechanical constraints that you should take in account in order, for example, for focus distances? Or is the speed of the line feasible with the expo times and the appearance, the reflectance of the object, or something like that? Or do you think there is a real-time algorithm that you may process directly on premise with commercial hardware? Those are the problems. Ignore minor issues and test it in the plant as soon as possible. So I think I always say to the team I am working with, especially with young guys, do not overthink. Do not remain stuck in the mud, over contemplating if you don't have all the details, all the data. Go for a quick and dirty solution and try to assess it as soon as possible. This is of paramount importance, because otherwise, if you are waiting to have all the data, you are, in the majority of the situation, you are wasting a lot of time to just gain an epsilon of advance.
Yeah, you'll never really have all of the information ever. Like, it's very easy to get, as you say, stuck in the mud with figuring, it's a little bit risky, and that's what prototyping is for, is to de-risk things before we get into production. I think you put it in a really intelligent way there.
So I just want to spend some of words on the team. What are we looking in a team? Experience, creativity, and overall, I think that especially in this applied R&D context, the can-do attitude is really important, because you won't find the complete solution on Google, on Stack Overflow, and nor in scientific papers. You will probably find a piece of the final solution here and there, but you have to connect all the dots with your creativity, with your experience, and so on. And you must believe that you will be able to connect all the dots. It's very difficult sometimes to explain this, but sometimes it's really a gut feeling. I know that we may do this kind of system. It's very difficult sometimes to explain why we can arrive to a suitable solution for the final needs of this kind of such system. And the last thing that I would like to say is that we have people from all over the world. We have an amazing girl from Karachi, Pakistan, who joined us for her Master of Science thesis. We got a PhD student, Pankaj, from India. We have now Madi from Tunisia, and so on. So this kind of technologies are attracting a lot of people from different parts of the world. And there is a chance for everybody who wants to make experiments and to build up their career upon these technologies, to make their experience together here. This was a very important message for me, because I really feel this thing.
Yes, and in fact, our own Dr. Satya Mallick here has been doing some AI career webinars recently. I recommend people check those out if they get the chance.
Yeah, so one of the things that I keep telling people, a lot of people think that if I'm in a different country outside, let's say Europe and US, the opportunities are not as much. And I don't believe that. Right now, people around the world, right? You could be in India, and you could, if you're good, if your skills are good, you can easily get a job working for a company that is in the US or the Europe. But more importantly, you will also find many companies within your own country that are solving local problems. And solving using AI, right? So this is like a big revolution, right? It is changing every aspect of our life. It is transforming all industries. So no matter where you are located, you will have jobs in this area. If not now, very soon, it is going to be, you'll have local jobs as well as jobs from other countries.
Yeah, definitely. And we see this with our competitions, over the years. The ones that tend to get the biggest response also are people, working in their local community to solve local community problems. And so it's really awesome to see how, as you say, it really is a global field, and you can get work basically anywhere, which is kind of paying off a lot of the promise of the internet and everything all these years.
Right. And even with OpenCV.ai, the consulting firm that supports the OpenCV library, OpenCV.org, it is very distributed, right? There are some people in the United States. Even in the United States, we are not at the same office location. We have people in Turkey. We have an office in Cyprus. We have people in Switzerland. So it is very, very distributed, right? So yeah, I think this is for a lot of tasks, you need a team at a location, but there is equally a great number of opportunities for people who are working remote.
Okay, I'm gonna show you now what may be in this moment, according to what you told so far. There is a lot of very good stuff, training material on the web. When we have a trainee, we have a couple of trainee per year from a local high school. And the first thing when they join us, we told to these guys and girls, please go to Learn OpenCV and try to study all the stuff on that website. And then we find out some kind of application or a part of the application, and then we build together with them. And what I'm showing you so far, Pick and Place AI application, Papaya, is the final project of a young guy, Fabio. And he made this from scratch in 2 months. He joined us last year. He just his first skill was Python programming, completely a newbie in computer vision. And look here, what he was able to do in 2 months. A complete Pick and Place automation.
Wow.
It's fantastic because there are, there is enthusiasm in what he coded in all the experimentation, and he finally was able to successfully deliver a complete Pick and Place solution. And now he's joining our team as a junior engineer, and this experience for him and his mates was really important, because there are a lot of blocks. For example, first of all, he learned how to interface to a camera using OpenCV, then to recognize this plastic preform. Then he programmed using RoboStudio the movements of the robot. And then we made the calibration together with the homography in order to make, the conversion between pixel and image coordinates and word coordinates. So it's a kind of putting upside down the traditional approach of learning that we have, at least in Italy, in the universities, where you start from theory and then you go toward the application. Sometimes this is very difficult, does not apply the same way to all the people. Because, for example, let's talk about the gradient descent algorithm. It's an optimization, a lot of mathematics, derivative, multivariable, and so on. But if you have a problem like in this way, and I want you to make the conversion, it's really, you have a problem and you want to learn the mathematics behind. It's not a projection map between projective spaces. It's like a conversion. So much more interesting for a lot of people. And you are not stuck in the mud because, okay, today I found out how to find the plastic object. Good. First, you are not stuck in the mud. You made your first step. And then I'm moving the robot. Wonderful. And then we are converting. So every day you are gaining and raising the bar. And so you feel really, really happy on what you are doing. And this is very important because as long as you are happy with your effort, the much you may develop a can-do attitude. That was the main feature for our team, for the guys in our team.
That's awesome.
Also, you know, when you build stuff like this, you get to give it an awesome punny name like papaya.
Yeah. Yes.
That's the real draw. That's the real draw.
It's part of the effort.
Yeah, I mean, hey, it's not going to be too long before all the good AI pun names are taken, so you got to get in there, you know.
So, what I would like now to do together, I don't know how many among the participants have ever been inside the plant, because usually there is no confidence. It's not so usual for people, for students to visit a plant, an industrial plant. And there is a kind of thought experiment that sometimes I tell to the participants of such webinars or conferences. And I ask them, how do you imagine a plant or a production line to be? And sometimes they tell me dirt, and a bad place, a noisy place. Okay, it may be, but let's make this experiment. Close your eyes and try to figure out if all the products coming out an industrial process are now disappearing, okay? So no more clothes, no more jewels, no more mouse, no more laptops, no more furniture, no more internet connection, no more building. Okay, our contemporary world strongly relies on industrial production. The technological level inside plants is absolutely astonishing. You have numerical models, you have automation, mathematics, physics, chemistry. So it's of paramount importance to support this industry, because otherwise our contemporary world would lose this meaning. So let's now go inside this agnostic plant and to see what it is possible to do with AI-based solutions. This is one of the applications we deliver in the last month, and this is a producer of fasteners, and he asked us, can you please check, for example, to control if the tray, these automatic trays, are empty or full with fasteners, and if there are some anomalous objects, because sometimes, for example, a maintenance guy may lose, for example, a piece of wood or a piece of nylon and so on. This is one of the solutions that guarantee that this kind of extraneous object, foreign object, do not go in the final packages and are not delivered wrongly to the final customer. And in some way, these trays also have to undergo a thermal treatment. And if you have plastics in the thermal treatment, you are making a disaster on the material.
Right.
So it's very important also from the environmental point of view to be sure that there are no contaminants inside the trays. This is another really astonishing solution that we delivered last year in December after a POC. And these are punched alphanumerical strings in order to track these cylinders inside a process line. this customer has 40 points of inspection along the production line, and the back part of the cylinder, the bottom part, sometimes is flat, sometimes is hemispherical, sometimes is reverted toward the internal part. And according to different mechanical surface treatment like phosphorization, like sandblasting, and so on, this kind of punched or alphanumerical fonts may be really damaged. And traditional sensors are very in increases in order to be able to read the data matrix that is punched as well in the center. We developed a solution relying on existing cameras in the plant that was able to find out the characters and to check also on the database to replace the most wrong characters, and to realize to arrive to 99.9% of the tracking of these cylinders. And the customer estimated that this is equivalent, the percentage of the tracking, of the lost tracking using traditional approach, that this 5% from 95 to 99.9 is equivalent to 300 work days per year.
Wow.
Because a worker has to shut down the automation, to go inside the confined area and to check directly, and then to go back to rearm and to put the string inside the PLC. This is another solution that we deliver, one of the first solutions we deliver. And what is interesting here is that we are dealing with the precision micromechanics of diesel engines for injectors. And the customer asked us if we were able to deliver a solution to find out this kind of scratches. And it was very a tricky solution because, you know, these are very shiny surfaces because are metallic surfaces worked by, you know, by, what is the English term? A CNC, a numerical control machine. And all this pattern is really difficult. So we found out a solution where we used different lighting techniques coupled with neural networks. This is another point that I sometimes want to focus to point out with the team guys, because previously we talked about the toolbox. Sometimes people just focus on the software. Software is just one of the tools you have.
Right.
The optics, the mechanics, the a priori information that you may get directly from the line, the lighting setup, the different optical filters that you may use. You have to leverage each of those tools in order to deliver a solution. There is no 100% software solution that may be effective. Sometimes it's much easier to study better the light and ad hoc apparatus in order to highlight the defects of the features that you want to intercept, to track back, before, instead of developing a particular model. And this is very important to realize that we are not delivering software solution. We are delivering complete solution. So you have to rely on different techniques. Okay, robustness is another feature. Here is a counter that you may also, it's just a toy demo made by one of the trainees. But the interesting is that in this case, you have a very easy segmentation from the background to the object. But sometimes when you are dealing with such application directly on production line, there may be not so easy to the difference between the background, because the background may change during production, may become dirt, may become consumpted and so on. So the flavor in this case that is added by using neural networks, convolutional neural networks, is increasing the degree of robustness of the solution. Okay, here is another example of the insights that you may give using a different approach. We have a kind of a marble surface, and from the standard picture, an RGB, a color picture, the surface looks really normal. But if you apply different lighting techniques, you may see that near the euro coin, there is a kind of mark here, and there are two big cracks that are not visible under standard condition, under standard light conditions. So it is, as I told you before, it's very important to think carefully about the acquisition apparatus, because it is part of the pipeline that you are going to deliver. And this, if you are looking, for example, to find this crack in this image, is quite easy, also using standard image processing, edge detection, or something like that. Okay, this is another solution, an embedded solution for washers, where we are looking to micro cracks on the external part of the ring. This is quite interesting solution because we managed to realize directly on an embedded camera with a GPU. What is the most interesting thing, in my opinion, in this application? That he has all the features to become pervasive, very cost-effective solution. You don't have to provide nothing except 24-volt DC. You don't need any kind of connection to a database, because on the first n object that are passing on the conveyor, the algorithm is identifying the right type of washer that is in production in that moment, and then it automatically loads the proper classification model for recognizing defects. And then there are also GPIOs that make quite easy the integration with the air blow that blows away the defective washers. So when I previously told that a human decision boost, if you are able to deliver in different points many cameras to check each point, each critical point of your production, you are giving a lot of data, and not only data like time series that are very difficult to be processed, but visual data. So people, we are, as humans, we are very specialized with our vision and brain. So it's very easy to understand what's going on by looking at images and this kind of information. This is another example where the speed is a critical factor. We have this dosing cap for shampoo or something like that, washing liquid. And we had to check here because it was thermocoupled, the thread part with the container, the bottom container. And at this speed, we had to check if they are correctly aligned within something like 1.5 degrees. Here is the feedback part, because very often the customer are asking or are looking for a quality control solution, and they are forgetting all the other information that may be useful. For example, in this case, the drill bit left a chip on this furniture. This is very important because, okay, they told me, okay, but the final operator with the hand can remove the chip. You're right. But what about in your process, you are stacking all this furniture, and the good surface with another good surface is coupled. And when you are stacking 100 of these wood pieces, this chip, before being removed, may be a mark on the surface of another panel. So it is very important to realize that all these AI-based solutions are also giving some information about all the tools and all the machines that are involved in the process. If the drill bit is leaving a chip, it's probably time to go to sharpen and to replace that bit. So you are not having a quality control information, but you are getting an information about the health status of your machinery.
Right.
Okay, this is the example of the harsh environment. The first time I met this problem, it dates back to 2009. And the customer designed this automatic grinding machine that was able to grind the slabs up to a temperature of 900 Celsius degrees. But the problem is that you do not want to make a full skin grinding, but you want to be selective to save, energy and material, and to grind just the defective part of the surface. But in 2009, it was just a big challenge to deliver a scanner because this object is 3 meters wide and up to 12 meters long. And a complete slab scan, it was about half a gigabyte, really, really hard in 2009.
Right.
And a couple of years ago, we managed to develop neural networks that were able to cope with such a difficult surface. And so the power of this electromechanical hot grinding solution has been freed now that you can have an automatic scanner to tell to the PLC where the surface has to be ground. Finally, the fuzziness. This was one of the most challenging things that where traditional image processing was found to be stuck in the latest years, because when you have to deal, for example, on the topping analysis for a pizza, it was really a messy to trying to use, for example, color filtering or blob detection and something like that. And in this case, object detection, segmentation, classification comes in hand as a powerful tool to make this complex analysis in the agri-food production. And lastly, the flexibility. Here we have a complex 3D object, and we have to scan in different parts because it is finally closed with the assembly. And we are starting from the 3D CAD design. We are taking automatically the points and commanding a robot, an industrial robot, with a camera to make all those images and to check for the piping and the mechanical fixtures, the pinout, and so on. Okay, so I have been asked by many customers, what are the limits of such application? And according to what I saw during these 20 years of experience in the industry, I realized that the limit of the progress is much closer to our inertia in accepting new technologies that may require to rethink and redesign sometime the process than to the technological possibility to go beyond the actual situation. Because when you are introducing a new kind of system inside your plant, it is very likely that you have to rethink something. You cannot introduce new technology, leaving all the processes as were before.
Yeah, that's an important point to make. Things necessarily change outside of just what you're changing with the new technology.
Yep. Should we take a pause to give?
I think this is actually the end.
And then come back.
I think this is actually the end of the presentation.
All right.
Is that correct, Danielle?
Yes, there is only, I think, one more slide. What we expect for the future. I don't know what do you think about, but according to what we may dig out in the new trends, there are many interesting things that are boiling down. For example, the use of synthetic data sets in order to be able to fast train before having data from the plant. This is one of the more interesting things, because I was really astonished when I saw last year GTC keynote by Jensen Huang,
Right.
because he quoted the three different themes that till that moment were more or less separated. That is physical simulation, neural networks, and hyper-realistic rendering. I think that the fusion of these three, let's say, fields will drive us as engineers, will be a complete game changer for engineers and for the design of industrial application. Because you may design an entire line and all the equipment working on the line and look and simulate all those things before starting delivering or even buying the hardware. And this will be one of the most exciting fields for us as engineers, I think. I don't know what you think about these topics.
No, I absolutely agree with it, and especially in industrial settings where the things that you're dealing with, they are man-made usually, right? So they are like in your case, you will showing washers and other pieces, which you can very easily render, right? If you know the material properties, etc., you can very easily render. In fact, for one of our clients, we had done this demo where they gave us some industrial, they were moving some disks and things like that, and they did not have enough data, but they gave us some material properties and things like that, and some pictures of that, and we rendered images for them, and we created an object detector purely based on synthetic data, and it worked for them. So I think that's a very big, especially NVIDIA's, I think it's called Omniverse platform. It is game changing in industrial setting. It can be, even outside industrial setting, it can be huge, but in industrial setting, it's a no-brainer, right? Because we are dealing with man-made stuff. We are dealing with material properties which are known, right? So I think that's a game changer.
Yeah, I think there's, again, with this technology, even though we've seen so many incredible advancements in such a short amount of time, the most interesting stuff hasn't even happened yet. and probably won't for some years. We're still kind of scratching in the dark. But it's a really impressive amount of scratching we've got done so far. I think, yeah, we should do our giveaway here. Folks are chomping at the bit. Danielle, if you would mind unsharing your screen, and I'll ask our trivia question to the good people in the OpenCV community. So, hey, everybody, that was an awesome presentation. Thanks so much, Danielle, for the insight. I think this is one of our most popular episodes in recent memory. So thanks again. If you need a reminder, or this is the first time you're joining us, one of the things we do every single week here on OpenCV Weekly Webinar is give away something to you in the audience. I am going to ask you a trivia question based on the slides from our guest. You will have the answer. You will have the capability to answer in the Zoom chat window. If you are the first person to answer correctly, you will win the OpenCV course of your choosing. You can go to opencv.org/courses to check out the course catalog. You'll also be able to pick the Mastering AI Art Generation course, which is not yet available, but will be available in May. If you have won in the last couple of months, please don't answer and give someone else a chance to win in the Zoom chat. Are you ready? Earlier in this presentation, our guest talked about 3 pillars. The first one was intelligent automation. What were the other 2? Didn't even get it out.
Did not finish.
I didn't even get it out. Like,
People are reading your mind, Phil. You have to be more creative in
like,
your questions
have they
now.
trained some kind of Phil AI that just knows like what I'm going to ask?
Maybe you should ask ChatGPT about the question you want to ask.
That was borderline. That was borderline insulting. I think
You had not
so.
finished your question.
I hadn't even finished it, but so it looks like Aluasin may have won here. Is that what you're seeing as well? Now
Yes.
I did ask for the other two, but they said all three. I mean, I don't know. Yeah, congratulations. Please send one email to phil@opencv.org. The answers we were looking for were human decision boost and process innovation. They got way too quick on that one. We're gonna have to start going out of the show for these or something, or maybe there'll have to be some kind of physical challenge or a scavenger hunt. Anyway, congratulations. Please send an email here. Satya, we're about 10 minutes past the hour here. Is there anything you'd like to say before why don't you take us home?
Yeah, thank you so much, Danielle, for this excellent presentation. I think
Thank you, Satya.
Yeah, people are motivated by real applications and not just software, right? It is a combination of software and all the industrial solutions that you develop. It's software, hardware, illumination, everything. So it gives us a sense of the field, not just as a software solution, you're not just using neural networks, but you're building complete solution. And it also gives us a very good sense of how the process works for you, right? How when you approach a client, what are the things that you look at, go to the factory and build the solution out. So all those insights were really illuminating, right? They, for people, especially for people who deal only with software, knowing that this is how an industrial solution is built, I think it was very insightful. Thank you so much for that.
Thank you too for accepting my.
Thank you. And Phil, thank you as always for organizing the show. And our audience, thank you so much for coming here every Thursday. And it's a real pleasure to host this show and have so many people show up every single week. Thank you.
Yep. We appreciate you folks. Take care of yourselves out there. Take care of somebody else if you can, and have a great day wherever you may be. If you happen to be in San Francisco, California for GDC, you can come find me on the floor. I've got OpenCV stickers. I'll give you one for free. Come say hi. I don't bite unless you ask.
Yeah,
we'll see you next week.
Before we leave, I just want to give a shout out to our sponsors, OpenCV.ai, which is consulting services in computer vision and AI. So if you have any computer vision or machine learning needs, please reach out to contact@opencv.ai and let us know about your problem. We'll see if we can help you solve the problem.
Yeah, they're like the Ghostbusters, but for computer vision.
All right. All right. Thank you, guys.
Thank you
Adios,
all.
folks.
Bye.
Bye.